Alright, hello. Today we're doing FRQ number 10. And so, um, first, part A, I draw a free body diagram with all the forces on this block. So I'll do that right now. So, there's an F. There's an F of K. There's an F of G. And there's an F of N. And those are the four forces acting on this block. Part B, as for the FK, so I know I can just do, okay, I'm gonna start off with just saying F of N is equal to F of G, and then in this case it's just gonna equal to mg, and m in this case, actually they give us that already, just 44.5 newtons. And so I can just take that, I can just say F of K is equal to Fn mu K, but F of K is equal to 44.5 times mu K is 0.2. So F of K equals negative 8.9 newtons. And it's negative because it acts against us. So it's negative. Alright, so now for part C, they want an expression for dx over dt, but dx over dt is just the derivative of position, which is velocity. They just want an expression for velocity. So we'll start off by setting up net force equals ma. So in this case, the net force is just equal to F minus Fk equals ma. F is given, which is just 8t squared. And then Fk, found in the last question, was just 8.9 newtons. But I won't include that here. So equals ma. M divide over. So 8t squared minus 8.9. M was given, or M wasn't given. They gave us the weight of the block, which is 44.5. You can divide by 9.8 to find that M is 4.54 equals A. Simplifying this, you get A is equal to 1.76 t squared minus 1.96. So now I integrate that. So by taking the integrated, I get V of t equals 0.587 t cubed minus 1.96 t plus 4, because they said that the initial velocity was 4. So that's it for part C. Alright, going to part D now. Part D just asks for the instantaneous velocity at 2. So let's do V at 2. I can just plug in all of this. So 0.587 2 cubed minus 1.96 times 2 plus 4. But okay, so just plug all that into your calculator, and then you should get 4.776 meters per second. So it's just magnitude, so no direction. Okay, so now for part E, they want instantaneous speed when the block is at position 2. So first thing I want to do is find the x of t function. So I would just integrate my velocity function, and so when I do that, I would get 0.145 t to the fourth minus 0.98 t squared plus 4t, and then there should be a plus c, but then the initial position is 0, so you just leave it like that. And so now I'll just say this equal to 2 is equal to 0.145 t4 minus 0.98 t squared plus 4t. But using your calculator, you get that t is equal to 0.5777. And so now I can just use that into my velocity function. V at 0.5777 is just equal to 0.587 0.5777 cubed minus 1.96 0.5777 plus 4, and then when you plug this into your calculator, 0. 7 times 0.5 minus 1.96 plus 4. I got 2.98 meters per second. And so it's just asking for instantaneous speed, so that's it. 2.98 meters per second. Alright, now for part F, they want average speed. But average speed is equal to distance over time. However, I can just use the fundamental theorem of calculus. And so from 0 to 8, I can just take the integral of the absolute value of my velocity function over 8, because that's the time. And so plugging that into your calculator, I got the average speed. It's just equal to 71.3 meters per second. Pretty easy. Right there. Alright, the last part, F of G, just has to graph the velocity graph. And so this is part G. And so I'm going to say this right here is my T in seconds. This is my V in meters per second. And so this is 0. I'll say this is increments of 2. Like that. And so I'm going to increment 20 up by every block. So 20, 40, 160, 180, 200, 220, 240, 260, 280, 300. I'm gonna stop it at 300 right there. Okay, like that. And then now, at 0 seconds, it's about 4. So I cannot draw that properly. So I'll do my best. I'll put that dot like right there. 2 seconds is about like 4.75. I'll put that right there. At 4 seconds, it's about 33.28. So it's like in the middle of these two. 6 seconds, it's at 117. So it'd be about like right there. And then 8 seconds should be up more slot right there. 8 seconds is about 285. So it's at the top of the graph. So it's about right there. So drawing a line like that. Graph that looks something like that. So that's it for this FRQ. Thank you for watching, and that's it. Thank you.